Welcome to Tech Teach.
So next we will see the virtual circuit network. So this is the second part of the packet switching. So first part was the datagram switching network. The second part of the packet switching is the virtual circuit network. So into this virtual circuit network, as the name suggests, it is virtual and circuit. So circuit network we have already seen. So circuit means there is a dedicated path, but it is virtual means there is a path, but that is not a permanent path basically. So here in case of virtual circuit network is a cross between a circuit switched network and a datagram network. So it is constituting some properties of circuit switched network as well as some properties of datagram network. It has some characteristics of both. So this is the virtual circuit network. So we will just see some more basics about the virtual circuit network. So we'll be seeing like what is addressing, what is three phases. So here also it is having three phases. What is efficiency and then delay and where it is used basically. So it is basically used into the WAN type of networks. This is the basic idea or the basic structure of a virtual circuit network. So into a virtual circuit network, first of all, this is a switch. So these are the switches basically. In case of datagram networks, basically the switches are called the routers. But here, this is the switches. So switches and these switches are connected with each other with a dedicated link and each switches are connected with some end system. So here the concept of identifier is used. So virtual circuit identifier. First of all, when we are going to send the data, we will be sending data in the form of packets itself. So data will be sent in the form of packets. This packet will be having a virtual circuit identifier. So whatever is the data, it will be having a virtual circuit identifier. So this is the switch. Okay. So whenever we are going to send the data into the virtual circuit network, along with the data, we will be sending a virtual circuit identifier. So what is what circuit identifier? So this identifier that is used for data transfer called the virtual circuit identifier is a small number that has only switch scope. It will be having a number, a smaller number that will be having only the switch scope. Switch scope in the sense if two switches are there. So if this is the virtual circuit identifier, so this virtual circuit identifier is suppose 25 along with the data. Then once it goes to here, so from here to here, once the packet is going from here to here, the VCI will change to suppose 20. So VCI will change. So only the scope of this VCI is up to a switch only. If it is going away from this switch, this VCI value will be changing. So how it is done basically, we will be just seeing whenever there is a switch, if we are sending a data, it will be having a VCI that is 14. Once it is crossing or it is passing from this switch, the VCI value will change to some other value. So this is the basic idea of the virtual circuit identifier. So each data will be having a VCI. That VCI is reaching to the switch. After going away from the switch, the VCI will be changing. So how it will be changing, we'll just see. So here it is used by a frame between two switches. So first of all, it is saying like it is used by a frame. So VCIs will be used by a frame between two switches. So its meaning is this is the switch and this data will be used at the data link layer basically. So because it is saying like it is used by a frame. So VCIs are used by a frame. So this data is converted to a frame. And we have already gone through like the TCP/IP is basically the one that will be having the physical layer and then data link layer. And in data link layer, the data or the message will be in the form of frames. So here whatever the message is there, that will be in the form of frames. So that's why this virtual circuit network will be working at data link layer. When a frame arrives at a switch, it has a VCI, it has a VCI. When it leaves it, it has a different VCI. This is the basic idea of the VCI. Note that a VCI does not need to be a large number, since each switch can use its own unique set of VCIs. So VCIs are basically just to identify the packet between two switches. So here each switch is basically having a switching table. So into a virtual circuit networks, so this switching table is having 4 different columns. So 2 columns is for the incoming message and 2 columns for the outgoing message. For the incoming, it will be you storing the port, means the data is coming from which port on the incoming side. So in data is incoming from the port 1, this port 1. Then what is it, VCI? And then once it is outgoing, so it will be going by which port, and then what will be its VCI. So this is the basic idea about the switch table. So basically, in case of virtual circuit switching, it uses the concept of circuit switching as well as the datagram switching, and instead of the routing table, it is having the switching table. Here also there are different phases. The first one is again here the setup phase. It is similar to the one that is utilized in circuit switching. So setup, so it will be creating a setup, means it will be going to give the addresses of the source and destination. Basically, based on the source and destination addresses, it will be identifying and going through each of the switches. It will be creating a setup path, or it will be creating a link basically, or the channel basically. After setup, there will be a data transfer, and after the data transfer is completed, the next one is the tear down phase. Here, different phases will be there, and each phases will be similar to the one that will be in the previous cases we have seen, but it will be done in some different manners. Some points we will be noting it down with respect to the virtual circuit switching. The resource allocation, here the resource allocation is done. Resource allocation is done during setup phase. So during setup phase, resource allocation will be done. This is the property of circuit switching, but it is having the property of circuit switching as well as the datagram. But in datagram, the resource allocation is done on demand. So in case of virtual circuit switching, the resource allocation is done during the setup phase or on demand. It will be done. It can be done either at the setup phase or it can be done on demand also. So this is having the properties of both circuit switching as well as datagram switching. Here, no end-to-end addressing, no end-to-end addressing as in the datagram. So in datagram there is no end-to-end addressing, but there is end-to-end addressing into the circuit switching. But here there is no end-to-end addressing is there, similar to the one that is having the property of datagram switching. Datagram switching. So also here, all packets will be following the same path that is established during the setup phase or while establishing the connection. Whatever the path is followed, the same will be followed by the packet. So that is having the combination of both circuit and the datagram, and it is implemented in data link layer that we have already seen. Circuit switching network is basically takes place in physical layer. Datagram switching network basically takes place at network layer, and this virtual circuit network takes place at the data link layer. Some more points we will just see. The addressing is done by 2 different methods. One is called the global addressing, another one is called the local addressing. So this local addressing is done by the virtual circuit identifier. So virtual circuit identifier is the local addressing, and in case of global addressing, so this global addressing in the sense, so that is basically the end-to-end type of addressing. So that is done while doing the setup page. So while setup page is performed, this global addressing is utilized. So that's why it is going to utilize the setup page also, that is the circuit switching, and the VCI that is going to have the local addressing between two switches. So that we have just seen in the previous slide. So you can just see here switching table is there. So if a particular data is coming with the VCI 14 at the here, this switching table is already having, like, it should be coming from port A having a VCI. Then once it is going out, it should be having a port 3 with a VCI 22. So this is blue one is having VCI 14. Then after going out, it is having the VCI 22. What VCI should be there after going out of the switch, that is given into the switching table. Similarly, for this data, second data having a VCI 77. So once it is coming, it will be already mentioned like 77 will be coming from the port 1. So it will be coming from port 1 of the switch. Then 77, once it is going out, it should be going out from the port 2 with a VCI of 41. So this is VCI 41. This is how the switching table is helpful for directing a particular data. Yeah, here the source to destination data transfer in a virtual circuit networks, how it is basically done. So if A wants to communicate with B, so device A wants to communicate with B, once it sends the data, that is 14, it should be going to port 1. So that is decided based on the switching table. So switching table will be having the port 1. It will be coming different data will be coming, different packets will be coming, or packets is basically here frames. So different frames will be coming at switch, but it will be accepting only that frames that are having the VCI 14. So VCI 14 will be accepted, and then it should be directed to port 3. Port 3 with a new VCI that is 66. Similarly, at here, it will be again looking for 66. If 66 is available into their switching table from port 1, then it will be accepting only. Then after accepting, it will be directing to the port 2 with a new VCI that is 22. Then again at this switch also at the end at the receiver. So this is how the source to destination data transfer is basically taking place into the virtual circuit network. So here we have seen like it is having 3 different pages. So setup page, and then data transfer, and then the tear down page. So in setup phase, it is further divided into 2 different steps. So first one is called the setup request. So setup page is divided into 2 different steps. So one is the setup request, another one is the acknowledgement. The second one will be the acknowledgement. So how the setup request is done into a virtual circuit network, we will just see. Once A wants to communicate with B, the first what it will be doing is, at that time this switching table was not updated. Okay, so the first step will be like it will be sending a setup request frame. So this will be the setup request frame. Okay, to the switch 1 it will be sending. So now here the switch 1 will be receiving the setup request frame, and this already knows like the data needs to be sent from A to B. Then it will be taking, like it will be updating. It's like port 1 will be having a VCI 14. So VCI 14 means this, it will be receiving this. This will be having a VCI of 14. Okay, then it through which port it should be outing. So it will be there into their outing this switching table. But what should the VCI that is not updated yet? So it will be just directing the packet, this request packet to the port 3. Then it will be going to here. Here again, this will be having already will be having like what will be the port, what will be the VCI for the incoming packet, and then to which direction it should be going, the port 2. So it will be port 2. But what will be the VCI that is not updated? It will be updated once the acknowledgement is received from the B. So it will be sending it to the switch 3. Switch 3 again will be receiving the packet. This is the request packet, setup request packet from port 2, and then it will be having a VCI of 22. Then it will be outing it to port 3, and then without any VCI. So VCI basically indicate like what will the destination. So destination will be once the packet request is going to here. So once this is received, request is received at B, B will be deciding like what will be the VCI of B. So B is having the VCI of 77. Okay, suppose the B is having the VCI request of 77, then it will be again returning back with acknowledgement. So acknowledgement step is the second one. So it is given in the here the setup acknowledgement. So step 2. So into the setup acknowledgement, it will be assigning the 77 and returning back the frame. So this will be the acknowledgement frame. So acknowledgement frame will be having the VCI of the destination. It will be going to switch 3. Now the switch 3 will be updating their destination VCI 77. Then it will be sending. So for this one, the destination one will be the this VCI. So this VCI will be sent here. So it will be updating VCI this one, and destination VCI for switch 2 will be 66. So 66 will be sent. So 66 will be updated here, and now 14 will be the one that is destination one. So it will be going to here VCI 14. So A will be assigned a VCI 14. So now once this is the collect setup phase. So setup phase is now over. So while doing the setup phase, the switching tables are basically updated for each intermediate switches. So once the switching table is updated, now means the setup is done. Now the data transfer will be taking place. So once the data transfer will be taking place, this is the one that will be followed. The data transfer will be taking place here. So once the data transfer is done, so after the data transfer, the next will be the tear down phase. So tear down phase is like the source into the tear down page, the source and the destination basically informing the switches to delete the corresponding entries. So in tear down phase, source and destination will inform switches to delete corresponding entries. Okay. So in setup phase, basically in setup phase, the global address here, the global address is used for path setting. And in data transfer, the normal data transfer will be taking place. So this is the basic idea about the virtual circuit switching. So here in virtual circuit switching, all packets belonging to the same source and destination travel the same path, but the packets may arrive at destination with different delays if the source allocation is on demand. So that we have already gone through. There is one big advantage of in virtual circuits network is even if resource allocation is on demand. So along with the dedicated link, there is another property like it can have the on-demand resource allocation also. So that is one of the advantages. So in terms of delay, similar to the previous one, like datagram switching, it's having like the delay. So because the circuit switching is not having any delay at the switches, at switch level, no delay, or we can say no wait time. No wait time is there. So similar to it is having no wait time. So the final total time that is taken is 3t for the transmission time, or transmission time basically that is for the during the setup. So for that setup and then delay, propagation delay time during the setup, or while this is basically while the data transfer. If data transfer is taking place, that will be for 3t transmission time, 3 propagation delay, and then setup time and the tear down time. So setup time, tear down time, and data transfer time. So that is the total delay into the virtual circuit networks. That is previous to the datagram and the packet switching that we have already gone through. And it is used in WAN type of networks. That is basically its application. So this is all about the switching networks that are available into the data communication network that we have gone through.